Hi guys, welcome to the channel. So in this particular video we are going to discuss about the absorption laws which we study in the UV spectroscopy. So in UV we discuss two basic laws which are the absorption laws. So the first law is Lambert's law and the second one is Beer's law. Right, so one by one we will study each of these. So first we will discuss about the Lambert's law. So this law states that you can write it down also. When a beam of monochromatic light passes through a homogeneous absorbing medium. So I think I should write it. When a beam of monochromatic light passes through a homogeneous absorbing medium, the rate of decrease in intensity of radiation with thickness of absorbing medium is proportional to the intensity of incident light. Now what this law states is that suppose we have a homogeneous absorbing medium, right? This is a cuvette and in this cuvette we have some homogeneous absorbing medium. So when a beam of monochromatic light means light of single wavelength, that is lambda. So when this beam of monochromatic light, that is light of single wavelength, when it passes through this homogeneous absorbing medium, what happens? Some part of this incident radiation, suppose the intensity initially was I naught, when it came in contact with this homogeneous absorbing medium, some part of this radiation will be absorbed by this medium and the remaining will be transmitted. So suppose I is the intensity of transmitted radiation, right? So if I naught was the intensity of incident radiation, then after this overall absorption some part will be transmitted and there will be some decrease in intensity of the radiation. So that rate of decrease from I naught to I, that will be proportional to the thickness of absorbing medium. That means suppose if we are talking about minus of di by dx, x will be the thickness of absorbing medium. So rate of decrease of intensity, because we are talking about the decrease, that's why there is a negative sign. So rate of decrease of intensity with respect to the thickness will be proportional to the intensity of the light, right? So this will be proportional to the intensity of light. Intensity of light. Now let's suppose we have some terms. So suppose we have the first term, that is I. So I will be intensity of radiation after passing through the thickness x. So this was the thickness x. So after passing through thickness x, intensity of light is I. Now, when we are about to remove the sign of proportionality, we are going to introduce some constant, or you can say the coefficient. So we are using here small k, that will be the absorption coefficient. Now suppose I naught is the intensity of incident radiation. So let I naught equals to intensity of incident radiation. So now we have defined all the terms. We will do a very small derivation. Now we have already studied that minus di by dx proportional to intensity of light. Removing proportionality, we can introduce k, so it will be ki. Taking this I onto left hand side and dx to the right hand side, we will get minus di upon I equals to k dx. Now integrating both these sides, intensity will go from I naught to I, x will go from 0 to x. Okay, so integrating this part, we will get log of I upon I naught equals to minus kx. I have taken this negative sign over here. So when we remove this log, this part will become e to the power. So it will be I divided by I naught equals to e to the power minus kx, because log goes here and become e to the power. Now from here we want to get the value of this intensity I. So I will be equal to I naught e to the power minus kx. Now intensity of absorbed radiation, whatever amount that was absorbed, if we want to find out that, so let it be I absorbed, that is the intensity which was absorbed by the medium. So that will be equal to what? The incident intensity of the incident radiation minus the transmitted radiation, right? So that will be I naught e to the power minus kx, this one which we have found right now. So what I'm saying is that suppose this was the medium and this was the initial intensity which was incident in this medium. After that some intensity will be absorbed by this medium, that will be I absorbed, and the remaining will be transmitted, that is here I. So this overall incident radiation was what? That was equal to I absorbed plus I transmitted. So if we want to find out I absorbed, so that will be what? I naught minus I. So value of I is what? I naught e to the power minus kx. So that's why we have got this equation. So from here I absorbed will be equal to I naught, we take it at common, so that will be 1 minus e to the power minus kx. So this will be the intensity of absorbed radiation. So this was all about the first law. This is the first law. Now we will discuss the second law, that is Beer's law. Okay, so in the next video we will discuss the Beer's law and the Lambert-Beer's law and also the limitation of Lambert-Beer's law. So from the next video onwards we will talk about these topics. So I hope this video was helpful for you. So far that's it for this video. Thank you so much for watching.